All right, here is question number 5 from 2019. You're asked to find the area of this region. So what is area in calculus? It's an integration question. So let's start there. Question number 5. You should always try it first, right? And then follow along if you can't. So we're going to integrate. What are the values from 0 to 2? And then what am I integrating? It's top subtract bottom. So what's the top curve? So one equation says 3 cosine subtract 2, and the other one says 6 and a negative parabola. So this is that negative parabola that starts there, been raised up. This is the cosine curve, where it's negative 2 plus 3. It's positive 1. It's right there. So we don't top subtract bottom. So we're going to go h at x subtract g at x. So that's a good start. But then it says you actually have to do it. So now I'm going to plug in h at x, which is 6 subtract 2, x minus 1 squared, subtract parentheses, negative 2 plus 3 cosine pi over 2x. It might be helpful to combine like terms or not. So 6 subtract negative 2 means 6 plus 2, that's 8. We have negative 2 x minus 1 squared, and then I'm subtracting 3, so that it's just a little easier to work with then. All right, now we have to integrate this. So the integration of 8 is just 8x. There is no hook here, so the 2 can stay in front, and we just add 1 to the exponent and divide. And then cosine, the hook should be pi over 2. So what it was, which is 3, over what it became, which is pi over 2. And then the integration of cosine is sine, not negative sine. And then we're going to integrate from 0 to 2. We can leave it as this. And then plug in 2. And then subtract and plug in 0. Don't assume this answer will be 0 when you plug in 0. It won't be. So plug in 2 and then subtract and then parentheses and then plug in 0. And that is the area. Question B says region R is the base of a solid. For the solid at each cross-section perpendicular to the x-axis has an area formula. So I don't need to know if it's a square or rectangle. It already tells you that base, the formula is this, 1 over x plus 3. And this is find the volume of the solid. So again, we're going to integrate. We're going to integrate from 0 to 2. It already tells me what the area of the cross-section is, that is, which is 1 over x plus 3. And then do it. That's it. So the integration of this is ln absolute value of x plus 3 from 0 to 2. So plug in 2, subtract, plug in 0, and you have the answer for the volume. All right, last one, part C. Now for this one, we're not evaluating, we're just setting it up. Write but do not evaluate an integral expression that gives the volume of the solid generated when that region is rotated about the line y equals 6. So y equals 6 is way up here. And I want you to notice there's a space. So 1, 2, 3, 4, 5, 6. It's up there. There's a space, here it is right here, between the line and this area. So we're going to have 2, when we rotate, we're going to have 2 circles. I'll do it right here. So we're still going to integrate. It's pi r squared. We're going to have a big radius and a small radius. So we have our big, subtract our small. And then we're going to go from what we're revolving around. So that's 6. So we're going to go top, subtract bottom. So we're going to go 6, subtract the bottom curve. So because we're just setting it up, we can go 6, subtract the bottom curve, which is g at x. That's the big radius. And the small radius goes from here to the top curve. That's 6, subtract the other function, which is h at x. And there's the setup to find that volume. And that's it. Mr. G Math over and out. Not even like barely 5 minutes. Did you try it first? Maybe. Anyways, I'm happy you did your homework. Until next time, stay positive. We got this.